Hello everyone, and welcome to the second page of 2.3, where we're solving linear differential equations. And so that was basically the notes, is making sure that we know how to find the integrating factor. Now that we know how to find the integrating factor, we're going to go ahead and try to solve these differential equations. Now, it says give the largest interval I over which the general solution is defined. That's not going to be hard. It's kind of like finding domain. Determine whether there are transient terms in the general solution. So transient terms are terms that when I take the limit as x goes to infinity, this term, f of x, if it equals 0, then it's a transient term. If it equals anything other than 0, then it's not a transient term. Right? And so what we're looking for is anytime we have a limit at x approaches 0 of our function, it gives us a 0. All right, and that's going to be kind of that last term that we're going to be looking at on after we solve. It's going to be that c part. All right, so let's go ahead and look at our first one, y prime plus 2xy equals x cubed. All right, and so again, we're looking for it to be in the form. I'll write that over here to the side. We're looking for it to be in this form. dy over dx is equal to, and then we have, not equal to, but plus p of x, y, that's equal to, and then we have our function f of x. And then our integrating factor is going to be e to the power of the integral of whatever that function is, that coefficient with y. Yes. All right. Whatever the dependent variable is in that case, it's x. Or independent variable x. All right, so let's go ahead and now find, well, it's already in our standard form, so because it's already in standard form, we can go ahead and find our not transient term, but our integrating factor. So p of x is just going to be 2x. So I'll write that here. I'll erase that and say p of x is equal to 2x. So then we're going to have e to the integral of 2x dx, and then let's just go ahead and integrate that. So we're going to e to the x squared. All right, now over here, I'm going to go ahead and write it in the term that we want. So we're going to have d the derivative of, and then we have our integrating factor e to the integral 2x dx times y. And then that's equal to, and then we'll do e to the integral 2x. That looks like a s. E to the integral of 2x dx times whatever our function is, which is going to be x cubed. All right. Now, we went ahead and did the integral. All right, and so we're really looking at this d over dx e to the x squared y is equal to e to the x squared times x cubed. All right, and so again, all I'm doing right now is just rewriting it to make, one thing is, as you're working this, you can go ahead, I can see how a lot of you can go from, okay, I'm looking at the first part, to already going ahead and writing it in this term, which is kind of the last part that we want to do before we integrate. All right, so we're going to go ahead and integrate. Again, whenever you need to fast forward, you can go ahead and fast forward if you're understanding all the work. So we're going to integrate both sides. And when we do that, the left side is just going to be e to the x squared y. On the right-hand side, we have e to the x squared times x cubed dx. Now, one thing that I know here is that, this is one that can be really hard if I don't know, a kind of a step that I want to do. Now, this is going to be integration by parts, but before I do integration by parts, what I do notice is I have e to the x squared. If I take the derivative of that x squared, it's going to be 2x. So I'm going to rewrite the integral on the right-hand side to be x times e to the x squared times x squared dx. All I did was I broke up that x cubed to be x times x squared. All right, and there's a reason why. So now, when I go ahead and do integration by parts, I'm going to say, well, u is going to be the algebra part, x squared, and dv is going to be the exponential part, x e to the x squared. And then when I find, when I integrate that to get v, I'm going to have just 1/2 e to the x squared. All right, and then du is just the derivative of that, which is going to be 2x. All right, now let's go ahead and do the integration. So this is just going to be the right-hand side of this. So I'm just going to say, all right, so equals. So I'm going to have uv, which is going to be 1/2 x squared e to the x squared minus the integral of v times du, which is going to be 1/2 e to the x squared times 2x dx. And then I'll go ahead and integrate that. So then I'm left with, on the right hand side, 1/2 x squared e to the x squared minus, all right, that 2 and 1/2 are going to go away, so it's just e to the x squared x. Again, I'm going to need a 1/2, so I have 1/2, and then that's just be e to the x squared, and then we have that plus c on the outside. Now, on the right-hand side, we can't forget we have e to the x squared y. So then on the, left-hand side, so e to the x squared times y is equal to 1/2 x squared e to the x squared minus 1/2 e to the x squared plus c. Now again, I'm trying to solve for y, so I'm going to divide everything by e to the x squared, and so then I'm going to be left with, and so here's my final answer, y is equal to 1/2 x squared, the e to the x squareds are going to cancel out, minus 1/2, and then plus c times e to the negative x squared. Now, my transient term, so I solved for the differential equation. It's here. All right, are there any values from start to finish where x could not be? No. So then the interval is going to be from negative infinity to positive infinity. And then we do have a transient term. All right, so we take that last term and we take the limit. I'll just do it up here. The limit as x approaches infinity. And then we do c e to the negative x squared. All right. Is that approaching 0? As x gets bigger, that's going to make that denominator, because again, this is really, or we could say the limit as x approaches infinity, c over e to the x squared. And since, the denominator is getting bigger, it's tending towards 0. So we do have a transient term, and the transient term is c e to the negative x squared. All right, and that does it for example 1. All right, now let's move on to example 2. Actually, I'll make example 2 another video, because each one could take a while.